Welcome to Mars, 4 billion years ago. A world of rivers, oceans, even, some astronomers said, artificial canals serving Martian cities. Today, the planet is a desolate wasteland. What happened to all that water? And might the same thing happen to Earth? Throughout history, people imagined Mars might be a planet like our own, perhaps even our twin. Peering through crude telescopes, early astronomers thought they saw seas and continents, even vegetation that changed with the seasons. In his famous map of 1877, Giovanni Schiaparelli called some features canali, meaning river or channel. Percival Lowell took that word literally. He thought the strange marks could be actual canals, dug by intelligent Martians. It seemed that many people agreed there must be water on Mars. So the first actual photographs from the surface were a shock. This barren desert landscape wasn't at all what many had imagined. Mars seemed a freezing, dead world, nothing like our own. The lack of water was also a problem for human exploration. Would astronauts have to bring all the water they needed from Earth? Could a Mars base or city artificially make enough water to sustain itself? Any dreams of colonizing Mars suddenly seemed remote. As we began to study the planet up close, the mystery deepened. Orbiters showed surface features that certainly looked like they had been carved by flowing water. Shorelines, deltas, oceans, islands and continents, nearly 40,000 river valleys. Perhaps the very channels that those early astronomers claimed to have seen. Were these really features created by liquid? Could there be some other explanation? And if water had been present, where had it gone and why? As we sent more and more probes and rovers to circle and roam the planet, the evidence that the landscape had been shaped by water grew stronger and stronger. But it wasn't until 2012 that NASA's Curiosity rover finally proved beyond all doubt that liquid water really had flowed across Mars. Exploring its landing site in Gale Crater, Curiosity imaged what had to be an ancient stream bed. These pebbles were rounded and weathered in a way that only liquid water could have managed. And it seems there hadn't been just a small amount of water on Mars. Using the geological evidence found in the ancient rocks and clays, scientists have estimated that there could have been enough water to submerge the whole planet in an ocean up to a mile deep. In the early solar system, perhaps Mars and Earth really had been very alike. So what happened? How did Mars get from this to this? Is all the water long gone, or does some remain? If so, where? The question was so crucial that for its missions in the 1990s and 2000s, NASA set itself a simple goal: follow the water. There were already signs that Mars wasn't a completely arid world. In 1976, the Viking 1 and 2 landers confirmed the presence of water vapor in the atmosphere. Other experiments strongly suggested water chemically bound in the Martian soil. As later probes explored, more and more evidence was found of water locked in clays and minerals. On Earth, this water would be released periodically by volcanic and tectonic activity, but Mars has little such activity, if any. So the water there has remained trapped in the rocks and soils for billions of years. It was the first clue where the water may have gone. But water in rocks wouldn't sustain human life on Mars. Future explorers and settlers might be able to extract some of it by literally cooking the rocks. But the energy and time involved would be immense and still produce very little. In July 2003, though, it was announced that the Mars Odyssey orbiter had detected huge amounts of water ice on Mars. We knew Mars had ice caps of frozen carbon dioxide. Now, finally, here was proof of frozen water, too, just inches from the surface. Those results were confirmed in 2008 when the Phoenix spacecraft sent these incredible images from the Martian North Polar region. This strangely shaped landscape is ice hidden by a layer of dust, so thin that the probe itself could dig down and reveal the ice beneath. More of the missing Martian water had been located. Further research at NASA's Jet Propulsion Laboratory suggests there could be a massive 1.2 million cubic miles of ice at or near the surface, with more buried deeper underground. This really was a game changer for possible exploration and settlement of Mars. It seems there could be plentiful water within easy reach, more than enough to supply astronaut needs, from drinking and living to agriculture. We could perhaps even create rocket propellant for the journey home, right there on Mars, rather than having to carry it all the way from Earth. Suddenly, Mars started to look like a place we really might be able to survive in, and planning is well underway. You wouldn't need a backhoe to dig up this ice. You could use a shovel, said Sylvian Piquet of JPL. We're continuing to collect data on buried ice on Mars, zeroing in on the best places for astronauts to land. On this map, produced by the JPL team, cooler colors represent ice found close to the surface. Warmer colors show deeper deposits. The outlined area could be the ideal place for astronauts to land, a region giving easy access to the ice, but avoiding the harsher polar conditions. So you're looking at the region of Mars where the first humans may set foot just a few years from now. Alongside these breakthroughs, other observations are even more intriguing. What were these strange streaks imaged by the Mars Reconnaissance Orbiter? Why do they change and evolve over time? Could this be proof of liquid water still flowing at or near the surface? It seemed impossible. Mars today is just too cold, with too little atmospheric pressure. It still remains a mystery, and some scientists think the marks could be caused by sand rather than water. According to astrogeologist Gretchen Bendix, based on what we know about how water behaves, if you're going to find it, it's going to be underground. One great mystery remains, though. What happened to those vast ancient oceans, lakes, and rivers? Their ghosts still mark the landscape so clearly today. So why did they vanish? And rather than water, according to astrogeologist Gretchen Bendix, based on what we know about how water behaves, if you're going to find it, it's going to be underground. One great mystery remains, though. What happened to those vast ancient oceans, lakes, and rivers? Their ghosts still mark the landscape so clearly today. So why did they vanish? To answer that, we need to look to the Martian skies. As well as studying the surface of Mars, we've also been investigating its atmosphere. And that's where scientists have found clues that could explain where the rest of the water has gone. As there definitely was liquid water on the surface at one time, the Martian atmosphere must have been far thicker and warmer than it is today. It's now believed that as Mars lacks a protective magnetic field and ozone layer, much of that atmosphere was stripped away by solar radiation early in the planet's life. Water molecules in the atmosphere were destroyed, causing a gradual reduction in pressure, allowing surface water to evaporate and escape into space. As pressure and temperature dropped even further, liquid water could no longer survive on the surface for any length of time. Gradually, the oceans would have shrunk and receded before the remnants froze over forever. That process of water loss still continues today. On Earth, water vapor that evaporates from the surface is carried into the atmosphere. There it condenses from gas into rain-filled clouds, falling back to the surface. But on Mars, that doesn't happen. Instead, the water molecules are broken down and lost from the planet forever. New findings from the Mars Express orbiter shows dust storms and even the planet's distance from the sun can increase the rate of water loss. So for billions of years, water has been slowly leaking away from Mars into space. Gradually, its atmosphere has thinned and the surface has cooled. The water that remained froze into ice, sank into salty underground lakes, or became locked into the crust of the planet itself. Estimates of how much of the water that was on Mars still remains vary wildly, from a few percent to more than 90%. Only further research, perhaps by humans in person, will tell us for sure. What is certain is that while Mars may not have its oceans anymore, it still has some of its water. You just have to know where to look. Luckily for us here on Earth, our planet's magnetosphere provides ample protection from the deadly radiation of the sun. From this currently stable planet, we can launch many more missions to Mars to carry on the search for any remaining water. The most recent mission with this objective is the Mars 2020 mission, or more commonly known as the Perseverance rover. So far, it has captured amazing images, strange noises, and revealed